All right, in problem number 1, they are asking us to find a point of inflection, and this time they give me the original, and since it's not a calculator problem, I have to go all the way to the second derivative of the function. I'm going to find the second derivative of the function. I'm going to set it equal to 0. That is not going to give me points of inflection. It's going to give me possible points of inflection. I'm going to take those possible points of inflection, I'm going to put them on a second derivative number line, and I'm looking for the sign to change, not just to equal 0. The sign must change to actually be a point of inflection, and you have the answer, and you can check it off on your paper. Number 2, they're asking us to evaluate a definite integral. We know that evaluating a definite integral is area under a curve. So by geometry, we're going to find the area of this region, and we know that that area will be positive. We're going to find the area of this region, and we know that area will be negative. The thing that you have to be careful of is when you're doing a definite integral, it's not total distance. You just go straight across. Whatever's positive stays positive. Whatever's negative stays negative. You don't make any changes to accommodate. The only time you're going to change the sign is when you have total distance. Problem number 3. I'm getting ready to pause, so be careful. Problem number 3. A number of students, when they found the antiderivative of problem number 3, had ln written on their paper. You may be one of those people that wrote ln on your paper. If nothing else, I need to make you understand, and this would be a red pen marking on your paper, that when you find the only thing that you get ln is the 1 over x to the first power. This becomes algebra, x to the negative 2 dx. When you find the antiderivative of that, you increase the power by 1. You get x to the negative 1 divided by the power. You rewrite that as negative 1 over x, evaluated from 1 to 2. You carefully handle the arithmetic, and you choose your solution. Problem number 4. In problem number 4, oh, this is commercial. We've already seen that. Problem number 4, they tell you some important things about the function. The function is continuous and differentiable. So those are criteria that are met for a possible theorem, and that's what they're really asking you about. Letter A, I hope you recognize, they were trying to say, does the mean value theorem apply here, where the instant rate of change is the average rate of change? Well, the criteria have all been met, so yes, the mean value theorem does apply. However, they're looking for what could be false. Letter B says, does the derivative have to be 0 somewhere in the interval? Well, the answer to that is no. They're trying to make this into Rolle's theorem, but as we all know, Rolle's theorem says that the endpoints must have the same y value. And if they don't have the same y value, we cannot guarantee that Rolle's theorem will apply. So we have found a statement that could be false. Therefore, the answer is B. In problem number 5, a number of students look at this, and what they see is take out the t, put in the x, but what they didn't do is read the question. The question does not ask you to find the derivative of a definite integral. Again, the question does not ask you to find the derivative of a definite integral. Yes, it looks like that's the kind of question that it wants to be. And I bet you that they put it on the test to see if students are going to really read the question, or if they're going to go, it looks like one of these, so I'll do what it looks like. What do I do here? You do exactly what it says. You find the antiderivative of sine, which is negative cosine, evaluated from 0 to x. You substitute negative cosine of x minus negative cosine of 0. That's literally how you handle that problem. You find the antiderivative, and you sub and solve. Number 6, we're finding the derivative. We're going to find it by implicit differentiation, so I get 2x plus first deriv second plus second deriv first equals 0. Get dy dx by itself, and if I do this correctly, you'll get negative 2x minus y over x. That's the first part of the problem. However, they give you an x value, but they don't give you a y value. Big whoop. It's your job to go over here and get the y value that goes with the x value so that you can plug the x and y in the derivative and select the correct answer. Number 7 is a classic sprinkle the algebra classic sprinkle the algebra. X squared divided by x is x. 1 divided by x is 1 over x. Now there's more to this problem that I want you to look at. When you find the antiderivative of this, you will get x squared over 2 minus ln absolute value of x evaluated from 1 to e. Many of you got that far. Do not let yourself down by not knowing the algebra that you need to access this problem. When you substitute e, you get e squared over 2 minus the ln of e. If you don't know the ln of e, then it is highly likely that you will now drop the problem because of your algebra deficiency. The ln of e, if you don't know it, it's a red pen time, and you must put it on your list of things that you must know. You must know it. The ln of e is equal to 1. If you didn't know that, it is a red pen day. Now I'm going to subtract 1 substituted, so I get 1/2 minus the ln of 1. Here is another fact that you must know. You must know that the ln of 1 is 0. If you don't know the ln of 1 is 0, it is a red pen day. You must know the ln of 1 is 0. When you clean that up, you get e squared minus 1 minus 1/2. 1 is the same thing as 2 halves, so 2 halves minus 1/2 is 3 halves, and you select your answer. Number 8 looks like it wants to be tricky, but it's really not nearly as tricky as you might think. And the first thing they're telling us is that g of x is always positive. And they're also telling us that f of 0 is 1. That's an important fact. So they're asking us about a derivative. So it seems to be reasonable that the first thing we would do is find the derivative using the product rule. First, derive second, plus second, derive first. However, they tell us that the first derivative of h is equal to f of x minus g of x. Agreed? Agreed? So the derivative that I found by hand must be equal to f of x times g prime of x. However, I noticed that on both sides of this equation there's an f of x, g prime of x, f of x, g prime of x. So I can subtract it from both sides. If I subtract it from both sides, then I will end up left with g of x times f prime of x is equal to 0. But now I go back to the given information. What do I already know about g of x? It's always positive, and if it's always positive, it can't be 0. Therefore, who has to be 0? What's the only thing left, ladies and gentlemen? If g of x can't be 0, f prime of x has to be 0. If your derivative is 0, then who are you if your derivative is 0? You are a constant, which graphs to be a horizontal line. There are two answer choices. Why is the answer E and not D? Go back to the given. F of 0 is what output? F of 0 is 1, so the answer is E. Remember, you can watch this video as many times as you want and as slow or as quickly as you want. Number 9, they're asking me to collect oil, accumulate oil, aren't they? That is area under a curve. So we're going to count blocks. This is 6 by 100, so this is about 600 barrels, 600 barrels, 600 barrels, 600 barrels. This is half of 600 barrels and another half of 600 barrels. I'm going to add up those numbers and I'm going to get about 3,000 barrels. Number 10, they're asking me for the instantaneous rate of change at 2, so I'm going to use the quotient rule, down to up minus up to down. I'm going to substitute in the value of 2 and I'm going to select my answer. Number 11 says I have a linear function. Children had trouble with this problem. I suggest to the children, if they say you have a linear function, why don't you make up a linear function? That seems reasonable to me. So I'm going to make up a linear function, and I'm going to call my linear function, I don't know, 5x minus 5. I just randomly made up a linear function involving 5s. The derivative of 5x minus 5 is, of course, bless you what, 5. The derivative of 5 is, of course, 0. So I just figured out that if I had a linear function, then his second derivative would have to be what? 0. If we anti-differentiate 0, we go back, as we just said a minute ago, to if we anti-differentiate 0, we go back to a constant. And if we evaluate a constant from b to a, it would in this case be 5 minus 5, which is 0. Number 12, we're looking for a limit, yes or no? You know, like I do, that in order for limits to exist, that the left limit must equal to the right limit. Agreed? Left limit must equal the right limit in order for a limit to exist. So I find the left limit. How do I find the left limit? I find out the value of y on the left-hand side as we come from the left. And so what I find out for the left limit is I get the ln of 2. The question is it equal to the right limit? So I substitute 2 into the other piece of the function from the right-hand side. 2 squared is 4, so I get 4 ln of 2. Since ln of 2 is not equal to 4 ln of 2, the left and right limits do not agree, therefore the limit does not exist. The next problem tells us that we have a vertical tangent at 2, 0. Vertical tangent looks like that. They ask us, where is this function not differentiable? Well, the function is not continuous at 0, and if this function's not continuous, there cannot be a derivative. So 0 does not have a derivative. Secondly, since we have a vertical tangent, the slope of our vertical line is undefined, which means that there is no derivative at x equal to 2. So where does the function not have a derivative? At 0 and 2. Number 14, they give us a position function and they ask us, when is velocity equal to 0? So I find the derivative of the position function, I set it equal to 0, and I solve. Number 15 is the fundamental theorem of calculus part 2 because they are asking us to find the derivative of a definite integral. The derivative of a definite integral. So I do, in this case, take out the t, put in the new function, and multiply by the derivative of the new function. Remember, this is the new function. The derivative of x is 1. Then I substitute the number 2. 2 cubed is 8. 8 plus 1 is 9, and the square root of 9 is 3. Number 16, they asked me to find the derivative. I'm going to use the chain rule. The derivative of sine is cosine of the angle multiplied by the derivative of the angle. The derivative of e to a power is e to the power times the derivative of a power, and then I choose my answer. Number 17, this is an original function whose name is f of x. Please do not be alarmed. This question was actually on your first semester exam, this very question. Twice differentiable simply means that you have a function that has a first and a second derivative. That's all there is to that, and then we put that to rest. They asked me to compare who's biggest, smallest, and medium. It's just like Goldilocks, medium, small, and just right, or something like that. It's very clear to all of us that the y value of the original function at 1 is clearly 0 because the picture says it's so. It's clear to all of us that the derivative at 1, although I can't give you the value, I know that the slope of the tangent line is what kind of number? Positive. I also know that the second derivative at 1, because the function is concave down at 1, the second derivative 1 has to be negative. I have been asked by the problem to put these numbers in order. This would be first, second, and third. That's how you put those numbers in order. Problem number 17 I just did. Problem number 18. In problem number 18, they want me to write the equation of a line, and guess what they give me? The y-intercept. So in this case, I would not go with point slope. I would go with y equal mx plus b, because they've already told me that the y-intercept is 1. So I can eliminate this one, I can eliminate this one, and I can eliminate this one, because none of those three have a y-intercept of positive 1. So now the problem boils down to the slope. To find the slope, I need the slope generator, so I find the derivative of x, which is 1, and the derivative of cosine, which is negative sine of x. I substitute in 0. The sine of 0 is 0, and 1 minus 0 is 1, so the slope is 1, so I'm going to select answer choice B. Number 19, they ask me for points of inflection. Make no assumptions. They give you the second derivative, so you have possible points of inflection at x equal to 0, x equal to negative 1, and x equal to 2. They are possible points of inflection. To guarantee that they actually are points of inflection, they must go onto a second derivative number line. I must choose values, substitute them into the second derivative, and then determine, does the sign of the second derivative change? If so, then I have a point of inflection. If not, I do not have a point of inflection, but I only have a possible point of inflection. Number 20, I'm literally going to find the antiderivative, x cubed over 3, and I'm going to evaluate it from negative 3 to k, and they told me that the answer to that problem is 0. I'm going to substitute, and I'll get k cubed over 3 minus plus 27 over 3, which is 9. How did I get that? 3 cubed is negative 3 cubed is negative 27 over 3 is negative 9, but I was minusing that, and that's equal to 0. I'm going to subtract 9 from both sides, and I get k cubed over 3 equal to negative 9. I'm going to multiply both sides by 3, and I get k cubed is equal to negative 27. I'm going to take the cube root of both sides, and k is equal to negative 3. Number 21 is a classic separate integrate. It is a differential equation. It is a derivative. When someone gives you a derivative and they say solve, you separate. You get dy over y is equal to k dt. When you find the derivative, this is classic PERT problem, but someone earlier asked me, how do you do this? So I'm going to do it. ln absolute value of y is equal to kt plus c. Now we use algebra 2 log properties to take it out of log form, and we get y equal to e to the kt plus c. We use exponent properties to rewrite that as c e to the kt, and the only answer that looks like that is b. Remember, you have packets that you can look every single one of these questions up in. There's nothing that you won't be able to find. We're looking for increasing intervals. They give us f, so of course we need to find the first derivative, which is 4x cubed plus 2x. We're going to factor out a 2x and get 2x squared minus plus 1. Set that equal to 0, so we get x equal to 0. From this, we'll get 2x squared equal to negative 1. So x squared is equal to negative 1/2. We can't take the square root of a negative number, so we get no points of inflection out of that. So the only answer, the only point of inflection is 0. Out, out, out. Make a number line, put 0 on it, make it first derivative, make your choice about which one's positive. 23, the graph shown is an original function f of x, and we're looking for his derivative. First thing, ladies and gentlemen, let's understand that this is not a parabola. I repeat, this is not a parabola. Do you understand why it's not a parabola? Therefore, it's not a parabola. His derivative cannot be a line. Agreed? So that one's out. We notice that the derivative is 0. The tangent line is horizontal here, so we're looking for a graph whose derivative is 0, so this guy is out and this guy is out. It's between A and C at this point. We notice that in this region from, I gotta sneeze. In that region, the slopes are all what? Positive. So we get A. That hurt. All right, questions. Number 24. You wouldn't believe how many people missed this problem because they did not read or think about what the question was asking. It wants the maximum acceleration. So you're right to understand that it is the extreme value theorem. You are correct to understand that the endpoints are 0 and 3. However, when you get the critical numbers, you need whose derivative? Acceleration's derivative. I need acceleration's derivative, and I set acceleration's derivative equal to 0. I solve that equation to find acceleration's critical number. So what I'm trying to say is I do not set acceleration equal to 0. I set acceleration's derivative equal to 0 because I want the maximum acceleration. This is an example of a question that you know how to do and you know the concept, but if you don't think carefully enough, you'll set the wrong function equal to 0. Number 25 is an area problem. It's either top minus bottom or right minus left. Certainly you're going to graph y equal to x squared, which is a parabola, and the line y equal to negative x, which looks something like that. There's a region of area enclosed. First thing we need to know is where does x squared equal to negative x. So we have x squared plus x equal to 0. And then we have x times x plus 1 equal to 0. So we have x equal to 0. Whoops. 0 and x equal to -1. So the area is going from -1 to 0. This is a top minus bottom. Which curve is on top? -x. Which curve is on bottom? X squared. Find the antiderivative, sub, and solve. The next question is a question that students want this question to be difficult, but it is one of the easiest questions in the entire packet, believe it or not. The reason that you don't have is because you don't try. You have to graph. You have points. Plot them. You have this mystery function whose name is f. What point is on f? 0, 1. What's another point on f? 2, 2. What do you know about f? F is continuous. That means that those 2 points are connected somehow. They're connected with a straight line. They're connected by going up and then back down, or they're connected by going down and back up. I don't know how they're connected, but I know they're connected. Now continue reading the question. When is your mystery function f of x equal to the line y equal to 1/2? When is your mystery function? No, that's not what they say. We want your mystery function to equal 1/2 twice. We want them to intersect twice. What are they saying? We want f of x to intersect 1/2 2 times. Well, then it would be a good idea to put the line y equal 1/2 on my graph. Now it's clear to me that I need to connect my 2 red points. But when I connect my 2 red points, how many times do I want to hit the blue line? I want to hit the blue line twice. Well, the only way to do that is for the y value at 1 to be smaller than 1/2, and the only choice that's smaller than 1/2 is a y value of 0. The y value can't be 1/2 because that means that they would touch once and then it would go back up. Average value. 1 over b minus a, so 1/2 from 0 to 2 of x squared times x cubed plus 1 dx. This is not normal antidifferentiation. What kind of differentiation is it? U sub u is equal to x cubed plus 1. Du is equal to 3x squared dx. I don't need the 3, so I'm going to get rid of it on both sides. I'm going to make the substitute. What? 1/2. Okay, so I get 1/6 the integral from, well, I'm not even going to put anything on it yet. So I'll get u to the 1/2 power du. Yes? I increase the power. I get 1/6 u to the 3/2 multiplied by 2/3. Yes or no? Yes or no? Yes. 2 goes into 6 3 times, and 3 times 3 is 9. Agreed? So we have 1/9 u to the 3/2. So when I evaluate, or when I put that back in, now I have 1/9 of u, which was x cubed plus 1 to the 3/2 power, evaluated from 0 to 2. Some of you have trouble with this, so let's walk through it fast. So let's run through it. 2 cubed is 8 plus 1 is 9, and then the square root of 9 is 3, and 3 cubed is 27. That's how you handle that arithmetic, and you do the work. Number 28, we're finding the derivative. By the chain rule, the derivative of tangent is secant squared of the angle multiplied by the derivative of the angle, which is 2. We're substituting pi over 6. 2 times pi over 6 is pi over 3. So we're looking for the secant of pi over 3 squared, which is the same thing as 2 over the cosine of pi over 3 squared. The cosine of pi over 3 is 1/2. 2 over 1/2 squared is 2 over 1/4. 2 over 1/4 is 8. And that is the end of this session. Play it back as many times as you need.